Scientists find a weird reason why tectonic plates get stuck 400 miles beneath the Earth's surface while they're diving and subducting. This is on Live Science by Stephanie Pappas. The Earth's mantle acts like a giant churn. It's circulating cool oceanic crust downwards towards the core, and there it heats up into a goopy solid, and then it rises again. It's a process that powers everything from plate tectonics to volcanism, and volcanic earthquakes, of course. But there are some hitches in the system, and new research reveals why. A slippery layer about 416 miles deep stops chunks of crust in their tracks, and it creates stagnant slabs in the middle of the mantle, the layer between the Earth crust and the core. That's the mantle. So why do they get stuck there? It's stalled out. There's no way to look directly at the mantle, but scientists study its dynamics using seismic waves from earthquakes. And by detecting the waves as they propagate, as they pass through the globe, researchers can construct a picture of what the mantle looks like. It's not unlike how radar can image objects using radio waves. What happens in the mantle is related to what's going on in the crust. The crust is made up of tectonic plates that ride across the mantle like rafts on a very, very thick sea. The consistency of the crust is similar to that of hot asphalt. In some areas called subduction zones, one of them we have, for example, in the Cascadia subduction zone, Juan de Fuca plate is one of the worst in the world, and it's just off the west coast of California. So they're called subduction zones. One tectonic plate dives under another, grinding chunks of oceanic crust down into the mantle. From seismology, Zong said, researchers knew that some of these slabs of crust don't always travel the full 1,860 miles to the core mantle boundary. Essentially, they get stuck partway down, particularly in the western Pacific Ocean near Japan at the Mariana Trench, for example. The slabs of crust seem to stall out at around 416 miles deep. In these areas, they seem to deflect and travel horizontally as much as 1,243 miles. The layer of mantle at that particular depth is unusual, Zong said, because the rock there goes through a sudden density increase, which is the result of pressure of all the rock pushing down on top of it. In the new study, Zong and University of Colorado graduate student Wei Mao built a computer model for the mantle's dynamics, including both this density increase and the past 130 million years of continental plate movements. And this is what the model mantle showed. This more complete model of the mantle naturally produced the same sort of stagnating slabs seen in the real mantle, the researchers found. And what seems to be going on, Zong said, is that the accumulated pressure of the overlying rock at 670 kilometers creates an area of reduced viscosity. In essence, the mantle is more slippery and less gooey. Quote, that reduced viscosity essentially provides what we call lubrication on the slabs, end quote. This is what Zong said. The chunks of crust are able to slip and slide sideways instead of continuing their downward plunge. This hitch in the machine is only temporary, though. The slabs are probably only trapped for 20 million years or so, Zong said, a blink of an eye in terms of Earth's history, but their dynamics might be important for some of the geological phenomena seen on the surface. For example, volcanic activity in northeastern China, far from volcanic arc of Japan, could be due, in part, to some of these slab dynamics. So the volcanoes in China, far from the volcanic arc of Japan, are due to the slab dynamics. The model does not answer all the questions about the stagnating slabs. It's not clear, Zong said, why the Western Pacific seems to give rise to so many of these stagnant slabs, while subduction zones near North and South America currently do not. There are also other mystery spots around the globe, we said. In places like New Zealand, there is still some disagreement between our convection model and the observations, so we need to reconcile those places. So they still have a lot more research to do on this, but that's what they found lately. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.